Now here's what we talked about in the second day of functions. The second day of functions, we talked about what it means to be a domain of a function. So remember, domain is your input. So we're talking about input values here. What can we plug in for x? What I want you to think of when you're thinking about that is really we're going to focus in on what are the restrictions of x. What can't x be? We're kind of going to go the opposite route of it. This is what I'm asking you here in this question. What can't x be? What makes the function undefined under the set of real numbers? So there's two distinct scenarios that will tell you when an x value can't be something. One of them is when you have a denominator. We know in math, we talked about this when we talked about slope, that the denominator cannot be 0. So if you see something in the denominator that has a variable, that's going to have a restriction on x. We want to know what x can be. So we got to figure out first what x can't be. So we would take that part and say that can't equal 0. And then you can solve it. I know x can't equal -4. So the domain for this one would be all real numbers except -4. -4 won't work. The other scenario we'll have is if we have a radical. What number can't the radical be? Well, under a radical, we can't have a negative number. So we need to think about how we can write that mathematically. So if we look at this part under the radical, this has to be positive in order to get a real answer. So we need to think about mathematically what we can write that as. That means that has to be greater than or equal to 0. So you can start by writing this inequality. That's going to say what that has to be. And then we're going to solve that. We're going to subtract the 5. That means x has to be greater than or equal to -5. So we just change the words a little bit here when we write this. We say all real numbers such that x is greater than or equal to -5. Any number that's greater than or equal to -5 will work in that, but anything else would be a restriction and can't be part of the domain. So the key here to these problems is recognizing and looking out for restrictions. Not every problem is going to have a restriction. So you can have some that are just all real numbers, but you have to look for them. So the restrictions, again, we have two restrictions. One, if there's a denominator that cannot equal 0. And two, if there's a part under the radical. It has to be the part under the radical is what we take. Under the radical has to be greater than or equal to 0 because it's got to stay positive to get an answer. So let's look at some examples. So this first one is actually just practice with what we talked about domain on the first day. We know domain is the set of all x values. So domain is x. So all you got to do for the domain for this one is list out those x values. That's all I'm going to do. It's going to be -3, -1, 0, 2, and 4. Then we get to the ones that have equations. So again, what you need to have, your radar needs to be on, you're looking for things that could potentially be restrictions. So if I look at number 2, there's a part of it that is going to cause a problem, and that's the denominator. I know that a restriction in math is the denominator cannot equal 0. So you take that, say that cannot equal 0. You do then need to solve this. That means x can't equal 3. So our domain is all real numbers except 3. That's the answer. In number 3, it's talking about circumference of a circle. So off the bat, looking at it, there's no mathematical restrictions on it. There's no denominators, there's no radicals, so we could at first think that it's all real numbers. But we need to remember what r stands for. R in this circumference of a circle formula stands for the radius. Can the radius really be any number? Well, no, because we're talking about a geometric object. So we have to think about geometry and what kind of answers we would need in geometry. R is going to have to not just be greater than or equal to 0, it can't be 0. Has to be positive, some kind of positive number, so R would have to be greater than 0. So that's a geometry restriction that we're looking at for that particular problem. And then the last one, we have a radical. So you're looking for what strange thing is happening here. We have this stuff is all under the radical. We have to ensure in math that under the radical is a positive number, or else we won't get an answer. We won't get a real answer, and we want real answers here. So we are going to take that part and say it has to be positive by saying it has to be greater than or equal to 0. And then we're solving here. So we would subtract the 8. We get negative 2x is greater than or equal to negative 8. And then you're going to divide by negative 2. And just be careful. You have to think about what happens when you divide by negative 2. You do need to make sure you flip that inequality symbol. That would be x is less than or equal to 4. So we would write this as all real numbers, such that x is less than or equal to 4. That's how we would state the domain. Anything less than or equal to 4, if we plug it in, is going to work. It won't give us a negative answer. And you can think about it. You can try numbers in there. 3 is going to work. 0 is going to work. Negative 5 is going to work because it's going to make it positive. All right, the last type of problems we're looking at are a little bit weird. Some people didn't really like what was going on here. So I'm going to try and explain this to you the easiest way I can. This is what's called the difference quotient. One of the difference quotient is something that you will use a lot in calculus. It has to do with derivatives. So this is just one of the most basic definitions in calculus. You'll see more of this, but since we talked about functions, this uses functions directly. It's something that you guys are able to do without even understanding the calculus. So when I give you this on a quiz or test, you would get the function, and then this part that follows I would always give you. So you don't have to memorize it, you just have to be able to use it. So we're going to use it one piece at a time. We're going to focus in on what this first part is asking us to do. This is just function notation, like from the other day. So all that's asking us to do is take this and plug it in for the x's. So instead of x, I'm going to plug in x plus h. So this is going to be x plus h squared minus 3 times x plus h plus 8. It is going to look weird, which is what makes this a little challenging. Every time we do a piece, we're going to keep it in brackets so that it can stick together with that group. And then it's minus, we're going to have another piece. That next piece says I need to do f of x. Well, f of x is just this piece right here. We're going to go ahead and plug that in as the next piece. So it's going to be x squared minus 3x plus 8. And then that's all over h. So that's the first step, is you have to follow the directions and plug in what they asked you to plug in. And now you have to simplify each part of this algebra problem down. You have to square this binomial here first. So when I square a binomial, I get I hope you said trinomial. It's going to be x squared plus the middle term. If you need to write it out over here to figure out what the middle term is, write it out. It's going to be xh plus another xh, so it's going to be 2xh plus h squared. Then we're going to distribute the negative 3x minus 3h plus 8. And then it's minus x squared minus 3x plus 8 over h. That minus sign we're going to have to distribute through. So I'm going to go ahead and distribute that through and change all these signs. Because now with those signs changed, this is what should happen, and it should happen every time. You should see things in this last group here that cancel with something in the first group. So if I look at it, this negative x squared cancels with that x squared. The positive 3x cancels with the negative 3x, and the negative 8 now cancels with the positive 8. The end group should cancel out every time. We're going to write down what's left. We have 2xh plus h squared minus 3h all over h still. Now I want you to be careful how you cancel this. I don't want you to cancel yet. I want you to pull the h out. We are going to cancel an h, but it has to be canceled out of everything, so we're going to factor it out first and write what would be left. We'd have 2x plus, we'd have an h left from the h squared minus 3 all over h. And then the h's do cancel. This is our answer. It's not going to look pretty. You have an x, you have an h, they're all mingled together, but that's what the answer looks like. So we're going to try one more of these. This one's a little bit different because they don't have an x anymore, they put a number in. So now we have to evaluate it with that number. In some cases it makes it easier, in some cases it makes it just the same amount of work. So we're going to go ahead and start with the first part. The first part says I need to plug 4 plus h in. That's again, they're just asking you to plug it in. Plug it into the x's here. So this is going to change to 4 plus h, and then it's going to be minus 2 times 4 plus h squared. I'm going to put brackets around that because that's my first part. Minus, I'm going to start with brackets for the second part. And this is f of 4. So that means I need to take 4 and plug it into each spot. So it's 7 times 4 minus 2 times 4 squared. All over h. And now we're going to simplify the algebra in here. So first step is to distribute that 7. In this next one, we can't distribute first because it has a squared. We have to take care of the exponent first. So I need to do, if you need to write it out, 4 plus h times another 4 plus h. That's going to be 16, plus the middle is going to be 8h plus h squared, all in brackets still, minus 28 minus 2 times 16. So this is 28, I'm going to finish my distributing, plus 7h minus 32 minus 16h minus 2h squared. Make sure you're distributing the negative 2. And then minus, this one I'm actually just going to leave it. I'm not going to combine those because if you notice in this next step, I would distribute this negative, and there's both going to cancel out. These ends two things, the 28 cancels, the 32 cancels with the negative 32, those are gone. And I lost for a second. This is still all over h. All over h. So if you look at what we have left, there's a 7h and a negative 16h, which we can combine. That's negative 9h minus 2h squared over h. And then we're just going to take the h out. So leave the negative behind, that's fine, but take the h out so we can get it to cancel. These h's cancel, we get negative 9 minus 2h, and that's our answer. Okay? We did do a couple of problems on Class Kick, which I would like to see you girls do at some point, just to make sure that you have a handle on what's going on before you take the quiz at a later date. Okay? So try the homework. I'll be available after school all week. If you guys need any questions, don't hesitate to come and see me. And I look forward to seeing you on Tuesday.